Hi and welcome back. So in the previous video, we talked about how you can parameterize a T-slot extrusion for length, and that was relatively straightforward. But that approach does fall short in some instances. So for this video, I'm going to import a part from the Vex Robotics V5 part library, and you can find this part on the GitHub page. In this video particularly, I'm going to be using the Vex 2751142, which is a 2-hole by 2-hole by 25-hole steel angle. So I will open that here. This is the part. And in the previous video, you can imagine that grabbing the end of this, so the cross section of this, and extruding it down, you'd be missing some pretty important geometry. For instance, you'd be missing these little notches that happen every once in a while. And you'd also be missing all of the holes, which is not exactly what you would want. So for this video, we're going to be going through the same parameterization, but we're going to imagine that we are cutting this part. So you purchased this part from Vex, which, is an okay decision, but their parts are extremely expensive in comparison to what they should actually be worth. So you could purchase this part from Vex, and then let's say, for instance, you wanted to cut it here. And that's something that you could do, right? So you'd be cutting it here using this amount, and then, for instance, cutting it here and using this amount. So we need to be able to define a starting cut distance here and like an ending cut length, so that you could cut it to any particular distance in between. For instance, let's say you were trying to line up these holes with something particular, you'd be able to do that with this technique. And for this technique, I'm going to do the simple Boolean, subtraction. So what I'm going to do is I'm going to come over here to part design, and I'm going to make a new part. So I grab the new part button here. I'm just going to put this body into part design. It'll show up as a base feature. So in part design, we're just going to quickly check and see where the origin is. And you can do that by selecting the origin and clicking the spacebar. And for this part, you can see the origin is like out here in the middle of nowhere. So we're going to move this part to a better origin. In particular, I'm going to line the origin up with this corner here, because I think that would be nice and useful. You don't have to do this. The technique doesn't actually require that you do this, but it is nice. So I'll come over here and I will measure from the base plate to this line here. Looks like it doesn't like that. I believe we saw that exact same behavior at the end of video 7 if you ended up sticking around. So I'm going to do the exact same kind of way around that. I'm going to just put in a sketch on that plane and then measure to the plane, or measure to the sketch. Oops. See, I selected the plane. I actually meant to select the bottom face. So we can see here that we need to move this up 72.28 millimeters. So we can go ahead and do that. So over here, position, oops, and I recall we had a similar misfortune with this particular section. So I'm going to come down here and move this up 72.28. Oops, looks like I put that on the wrong axis. So we will change that back to 0. And let's see, oops, you actually can't see that part because it's being hidden. So I probably did have the correct axis. So come back down here, 72.28. Alrighty, we can see that this part is now up here. And then we just have to move the thickness to the left. So I'll come over here, grab the measure tool again, and measure the thickness of this. And it is thinking. It's probably going to have a big think because it's going to be comparing the thickness of all of these holes and everything to find the smallest thickness, and that is probably not great. I guess what I should have done is I should have, measured from this particular point to that particular point, but that's just a limitation of this particular section of FreeCAD. And we've got 1.17 millimeters, and I recognize that as kind of a standard sheet metal thickness. So we will move this 1.17 millimeters into the negative Y. And that should line that up approximately, probably not exactly, but very, very close with the origin. And I'm actually going to get rid of this body. And then up here, if you click this button, it'll get rid of your measurements. So now we have a clean body. And let's grab a body. We'll see if this part design object, yeah, so it ignores the translation we put onto this. So what I'm going to do to get around that is I'm going to do some kind of hacky bit, but I'm going to come over here and I'm actually going to Boolean add this into the part design object. We'll see if that helps. It does not like that either. Very, very interesting, very interesting. Very interesting. I wonder if we remove that, it does not move. How interesting. Well, let's see. We can come over here to part, and we can wrap this in part and then wrap part in part design. So come over here and I can, let's see, what do I want? I want Boolean fragments, I believe. Ooh. Let's see. I do not want Boolean fragments. I want, let's try make compound. Okay. And then let's wrap make compound in part design, of course. Gotta end up in part design. Okay. So now that we're in part design, so a little bit hacky. I would appreciate it if in the future part design would take into consideration the translation of the original body. I'm also noticing that this is horribly not centered. And of course we can fix that, no problem here. So grab this, grab myself a line, and we will measure to that line, and I'm going to line up the base of this with that, so that we're kind of on the edge of this. I'm sorry if this is a lot of prep work for nothing, but you know, I like my parts looking nice. So this is 55.82. So we will come in here to compound, and this is on the x-axis. We actually need to do minus 55.82. Alrighty, we see it's moved there, and then I shall get rid of those lines, and I'll delete that sketch. Okay, so now that we have this part situated like we would like it, I can describe how we're going to modify it. So what I'm going to do is I'm going to use the sketch tool. I'm going to draw a box, and we're going to extrude this box symmetrically around this part. So we end up with a kind of cube. And then now that we've got this cube surrounding it, we will just use the Boolean operation to subtract the part here from the rest of the cube. And we should just be left with a part that fits inside of the cube, or just the part that's inside of the cube. And what that allows us to do, let me get rid of my drawing there, is it allows us to choose a distance from end and then a length of final part. Or you could pick two lengths, or you could pick distance from end both times. It doesn't matter too much, but this allows you to pick exactly what section you want to be coming or to be cut from this part. So we'll get started on that. I'll grab the sketch tool in Part Design here, and we'll just sketch on this plane. You could also sketch on the Y or the ZX plane, and it wouldn't make all that much of a difference. And I'll grab a square, and we'll just make this symmetrical about the axis here. Doesn't actually matter. It just needs to be big enough to cover the axis. And then I'm going to close this temporarily, and we're going to come over here to Spreadsheet and make a new spreadsheet, and I'm going to call this first one distance from end. Oops, not distance front end, distance from end. Okay. And we can space that out a little bit, and I'll call the second one total length. And of course this is in millimeters for both of them, because that is the default. And for instance, I will just pick, let's say 20 and 200. And this, we will name this an alias, give this an alias so we can reference it later. And I will call this from end and total length. And I'm just now noticing my from end. Get rid of the extra n there. And just come back to our part and switch back to the sketch. And I will grab the horizontal. And I guess in particular, we're coming from this side. This part, I believe, is symmetric, or at least it appears to be symmetric. So the end that we're coming in from doesn't matter for this. But if it did, then maybe you'd want distance from end 1 and distance from end 2 to explicitly define that. Or maybe you can do some kind of fancy calculation, but it doesn't really matter for this. You can do that all in the spreadsheet. None of it is too special. So I will give this a spreadsheet dot from end. Okay. And you can see it's made that positive. So we will do negative spreadsheet from end. Should flip it over to the other side. Okay. Looks like that's doing good. And we'll grab the horizontal dimension from this one, and this will be negative spreadsheet dot total length. Okay, looking good. It's looking good. So then I'm going to create another body in part design to house my Boolean operation. So this body here, come over to this sketch and I'll drag this over to the active body. It does not like that, so we'll place a link here, move it to the active body. Does not like that either. Running into all kinds of trouble today. Let us see. So if we pad this, it says cannot use selected object. Selected object must be in the active body. Consider a shape binder. So we can shape binder this probably. Here, once again, I talked about this in the last video, blue shape binder or green shape binder. For this instance, I'm going to be using the blue shape binder because it's more restrictive, but it should not matter for this. So sketch, and I guess we can add geometry. I'm not sure it wants me to select edges. Gotta go through and individually select edges, I guess. Okay, now we've got this shape binder. We can hide that. And can we extrude the shape binder? We can, in fact. Dimension, 2 dimensions. And we'll just make these long enough to go all the way through the part. So maybe 10 and 40. So that in fact does go all the way through the part. And then grab body 1, body 2. We want a Boolean operation. Let's see, it's thinking here, thinking quite a bit. And we actually want a common operation, I believe. We'll see what it spits out, but I believe common gives you just the section that intersects both objects. It is thinking quite a bit, so I suspect that is the correct operation. Oh, yep. So there we can see that this did give us exactly what we were looking for. This is quite a slow operation. I suspect that is because this part in particular, since it's an imported part, has quite a bit of geometry in it, and this is kind of bogging down FreeCAD. But that's okay. As long as you're not editing this thing too much, you should be fine. And I believe this is going to be the end of the video. So once it comes up here, we can show that it does in fact work and you can edit it using the spreadsheet, but I suspect that will take quite a bit of time to reload and recompute. This is a much heftier operation than what I showed in the previous video. But here you can see that it did in fact cut on both sides. So if we come in here in the spreadsheet, and for instance, this particular part is, looks like it's gonna reload since I edited this part of the spreadsheet, even though it did not change. So we'll wait for that to reload, and then I will measure the length from one side of the object to the other side of the object. And then I will change the length, and we will see that it actually does shrink, and it does in fact move as one would expect it to. But yeah, this is a pretty hefty operation. I'm surprised that it's taking so long. Normally Boolean operations are fairly quickly, or fairly fast. Um, this particular part does seem to take quite a long time to load. It is possible it's got a very large amount of geometry with all of these holes in it. You might actually want to go through and recreate this yourself in FreeCAD without all of these fillets and unnecessary geometry. Like, oof, this particular section of geometry looks quite nasty, quite nasty. I imagine this is their attempt at modeling a flat sheet that's been cut out and then bent along that edge. Let's see, so if you recall, the part looked like this, and on the right side here, we've got a little bit of this kind of just very end of the, I guess, cutout there. And on this side here, we've got this, very close to the cutout there. And if we come over and grab the measure tool, we grab this end, we grab that end. This is in fact 180 millimeters long. So I'm going to leave that up there so that we can see that it changes, because these parts, these measurements don't update unless you actually come up here and click the update measurement button and recalculate the dimensions button. So I'm going to come over here to the spreadsheet and I will edit this section here and we'll just decrease it by 40. So we should see the part shrink down just a little bit and we should see it kind of move together. And the good thing about doing it this way, as opposed to some of the other ways, is this should like maintain the part naming as long as you're not using a version of FreeCAD with the topological naming problem. If you are using a version of FreeCAD with the topological naming problem, I would recommend that when you go to do any type of mates or any type of modifications, or I guess any type of kind of mating two things together, hooking two things together in one of the assembly managers, that you actually mate to the original shape binder here. Or I guess you come down here and you come over here to compound, body, base feature, and you mate to the base feature, because that way your topology doesn't change when you change the length here, because this will go through and it will update the naming of all of this. If you are using a version of FreeCAD that does not have the topological naming problem, I wouldn't worry about it. This should be taken care of. But getting back on track here, you can see that now our distance is in fact shorter, and this is completely controlled by the spreadsheet, which is exactly what we were looking for. So I would recommend doing this to any custom or any commercial off-the-shelf parts, so any COTS parts. This way you can keep track of exactly where you want these parts to be cut, and then also what part this is cut from. So in particular, I would save this file as, modified vex, 11 whatever the vex number is, right? So that you can keep track of, I want this part cut from, this other particular part, and then I want it cut, exactly here and here, right? I want this part cut 60 units from one end and 200 millimeters from the other end, right? And this will be exactly the same as what is in your CAD when you go to make it in real life. So I hope you learned something from this video, and let me know if you thought this was a good video, or if you thought this was useful, and have a nice day.